LPIC 1. Topic 101 System Initialization. Armand Shariarian. System Initialization. Apart from the kernel, the operating system depends on other components that provide the expected features. Many of these components are loaded during the system initialization process. Varying from simple shell scripts to more complex service programs. Scripts are often used to perform short-lived tasks that will run and terminate during the system initialization process. Services, also known as daemons, may be active all the time as they can be responsible for intrinsic aspects of the operating system. The diversity of ways that startup scripts and daemons with the most different characteristics can be built into a Linux distribution is huge, a fact that historically hindered the development of a single solution that meets the expectations of maintainers and users of all Linux distributions. However, any tool that the distribution maintainers have chosen to perform this function will at least be able to start, stop, and restart system services. These actions are often performed by the system itself after a software update, for example, but the system administrator will almost always need to manually restart the service after making modifications to its configuration file. It is also convenient for a system administrator to be able to activate a particular set of daemons. Depending on the circumstances, it should be possible, for example, to run just a minimum set of services in order to perform system maintenance tasks. Note: strictly speaking, the operating system is just the kernel and its components which control the hardware and manages all processes. It is common, however, to use the term operating system more loosely, to designate an entire group of distinct programs that make up the software environment where the user can perform the basic computational tasks. The initialization of the operating system starts when the bootloader loads the kernel into RAM. Then, the kernel will take charge of the CPU and will start to detect and set up the fundamental aspects of the operating system, like basic hardware configuration and memory addressing. The kernel will then open the initramps, initial RAM file system. The initramps is an archive containing a file system used as a temporary root file system during the boot process. The main purpose of an initramps file is to provide the required modules so the kernel can access the real root file system of the operating system. As soon as the root file system is available, the kernel will mount all file systems configured in /etc/stab and then will execute the first program, a utility named init. The init program is responsible for running all initialization scripts and system daemons. There are distinct implementations of such system initiators apart from the traditional init, like systemd and upstart. Once the init program is loaded, the initramps is removed from RAM. SYSV standard. A service manager based on the SYSV standard controls which daemons and resources will be available by employing the concept of run levels. Run levels are numbered 0 to 6 and are designed by the distribution maintainers to fulfill specific purposes. The only run level definitions shared between all distributions are the run levels 0, 1, and 6. Systemd. Systemd is a modern system and services manager with a compatibility layer for the SYSV commands and run levels. Systemd has a concurrent structure, employs sockets, and dbus for service activation, on-demand daemon execution, process monitoring with groups, snapshot support, system session recovery, mount point control, and a dependency-based service control. In recent years, most major Linux distributions have gradually adopted Systemd as their default system manager. Upstart. Like Systemd, Upstart is a substitute to init. The focus of Upstart is to speed up the boot process by parallelizing the loading process of system services. Upstart was used by Ubuntu-based distributions in past releases, but today gave way to Systemd. Initialization inspection. Errors may occur during the boot process, but they may not be so critical to completely halt the operating system. Notwithstanding, these errors may compromise the expected behavior of the system. All errors result in messages that can be used for future investigations, as they contain valuable information about when and how the error occurred. Even when no error messages are generated, the information collected during the boot process can be useful for tuning and configuration purposes. The memory space where the kernel stores its messages, including the boot messages, is called the kernel ring buffer. The messages are kept in the kernel ring buffer even when they are not displayed during the initialization process, like when an animation is displayed instead. However, the kernel ring buffer loses all messages when the system is turned off or by executing the command dmesc clear. Without options, command dmesc displays the current messages in the kernel ring buffer. $dmesc. The output of dmesc can be hundreds of lines long, so the previous listing contains only the excerpt showing the kernel calling the Systemd service manager. The values in the beginning of the lines are the amount of seconds relative to when kernel load begins. In systems based on Systemd, command journal will show the initialization messages with options B, boot, K or dmesc. Command journal list boots shows a list of boot numbers relative to the current boot, their identification hash and the timestamps of the first and last corresponding messages. $journal list boots. Previous initialization logs are also kept in systems based on Systemd, so messages from prior operating system sessions can still be inspected. If options B0 or boot equals 0 are provided, then messages for the current boot will be shown. Options B-1 or boot equals -1 will show messages from the previous initialization. Options B-2 or boot equals -2 will show the messages from the initialization before that, and so on. The following excerpt shows the kernel calling the Systemd service manager for the last initialization process. $journal B0. Initialization and other messages issued by the operating system are stored in files inside the directory /var/log/. If a critical error happens and the operating system is unable to continue the initialization process after loading the kernel and the initramps, an alternative boot medium could be used to start the system and to access the corresponding file system. Then, the files under /var/log/ can be searched for possible reasons causing the interruption of the boot process. Options D or directory of command journal can be used to read log messages in directories other than /var/log/journal/. which is the default location for systemd log messages. As systemd log messages are not stored in raw text, command journal CL is required.